Hello CS1 students and YouTube world. This is Dr. Satish Singhal, Professor of Computer Science at Community College, Torrance, California. I'm doing design example number 2 that helps you kind of understand how you should do design of your lab 2. Designing lab 2 means how to do IOAA. We are going to take an example here, a financial example that does a computer program for monthly payment on a loan taken. So typically you might take a loan for a car and so on. So what will be the monthly payment that you'll have to make in order to pay the loan back? Okay. So as is the system for writing computer program, first step in writing a program is developing something called IOAA, which is input, output, analysis, and algorithm. Once your IOAA has been refined and algorithm is written, in old days, people used to run algorithm through a desk check to make sure all computations are being done correctly. These days, once algorithm looks good, we just try it out in the source code, in the compiler, fix compile error, run it. We still test it against some set of data and make sure program works and gives expected output. Otherwise, we have to debug it to remove compile errors, runtime errors. Okay, so focus in this video, first video, is on developing IOAA for a computer program that we have been asked to write. You always start out with the problem statement because that is your foundational description. In bigger software, it will be a whole document, and real life software writing, a document is just a starting point. There will be extended interviews with the company personnel, company that asked you to write software. If software division is inside your company, you will still ask a lot of questions from part of the company for which you are writing software. Here in this class, we will just try to take our clue from the problem statement. So IO means that I map all the inputs, map all the outputs, analyze the program, and write the algorithm, and after that I'm ready to write my source code. So we take our clue from problem statement, at least for the input output. Rest we will search formulas to be used or any other condition to be met which will be part of the analysis. Okay, so let's read that. A person takes loan from a bank at some annual percentage interest rate for some years. So this gives us a clue that amount of loan will be a user input, annual percentage rate will be user input, and for some years, that means if we wanted to find monthly payment, then 12 multiplied by number of years will be my payment. Okay, this program computes monthly payment on the loan taken, and then again we are actually saying already in the problem statement that program takes user input for loan amount, annual interest rate on the loan, and number of months over which loan will be paid by the client, and then program outputs the monthly payment due in whole dollars and whole cents. Okay. All right. So this problem statement is enough for us to map out input and output. So let's do the input table. Data input, or you can say input table. What is the purpose? Map out all the input variables. What does mapping out means? Mapping out means this, that you choose the variable name for each input variable, and don't forget C++ is a case sensitive language. If I choose name all lowercase LOAN, later on I cannot make any of these letters uppercase. C++ is case sensitive language. Alright, so it already says it takes input for loan amount, annual interest rate, and number of months over which loan will be paid back. Now next, first we choose the variable name. Loan is a good name for loan taken. You can say interest rate, I rate, rate. They are all fairly descriptive names. And then number of payments to be made over the life of the loan, that's a num-PMT. You can use longer names if you like, but for me these names are pretty descriptive, so I'm just going to live with that. So next thing is to assign data type, and that's where it's very crucial how to do this correctly. Okay, loan amount generally will be whole number, 15,000, 10,000, 9,000, something like that. But here's the problem. I cannot use, even if it's a whole number, I cannot use int data type for that, because if you go to bank and you say, I want loan for $10,000, 50 cents, 10,000.5. A bank cannot tell you that, hey, we don't give loan in cents. That's impossible. They have to give you loan. If you want 50 cents more, they have to give it to you. So even when numbers in general practice are whole number, if money, since it can contain cents, it's always should be in double type. So here's the rule. Money, unless it is in pennies only, is always double type, because it could contain cents and it has a floating point nature. That's why I'm saying loan amount is the amount of loan taken, may have pennies included. So rule in this class is CS1 rule. Unless money is in pennies, it's when it can be cents. Int type. It's always double type. So don't even make this mistake ever to choose int type for dollar amount, because it could be dollars and cents anytime. Okay. Now rate will be 5%, 5.1%, 5.2%. Has to be double type also, allowing us the room to have decimal parts in the interest rate. Okay, so now I'm not sure. It's not in decimalized fraction. Oh, okay, yeah, actually it is. In this case it is. The video I did there, there was a video earlier where I showed how to convert C++ math to C++ formula. There I took interest rate in annual percent, but here rate is monthly interest rate in decimalized fraction. What does that mean is that I'll take annual interest rate and somewhere along the line I will divide it by 1200, user entry to 1200, and that would be my interest rate. Okay. Here's the issue. Who would think number of payments is not a whole number? You'll make either 5 years 60 payments, 4 year 48 payments, 3 years 36 payments, and so on. That's a whole number. So that has got to be in type. It's a big mistake to use double type for that, because double type consumes 4 bytes more. And even if you use float, which is 4 bytes only, then you have to put up with the imprecision. Okay. So numbers, data that cannot have decimal parts ever, like number of payments, number of students in the class, age on last birthday, number of chairs in a room at a certain time, these are all whole numbers. You should never use double data type for that. Okay, so that's why I have to use int here. Okay, that's my mapping out of the input variables for this software that I'm developing. Okay, style of the table, I'm very inflexible about how they need to be done. You have to have a table where the first column is variable name, second is data type, third one is remark. Remark sometime may give a unit, like unit is the dollar here, and that's understood, we are in US, so it's dollars. But like in first lab, there was a weight as input variable there. Unit of weight was pounds and unit of height was feet. So always includes whatever you wish to record about the input variable and their units, if there are any units in this. And also I'm showing you this here. See the design of data output table and data input table above. Your table should match this design. If input and output parts are not done in table, I will take off ones because it's very hard to read. Whatever I'm suggesting that makes my job of reading easier is your contribution to this course. If you are not going to make this simple contribution, then we have a problem. Okay, data output is, notice this verbiage here. Program outputs monthly payment in whole dollars and whole cents. So I'm going to have two variables for that. Dollars, whole dollar will be integer, whole cents will be integer. But whatever formula I use is going to give me monthly payment as double type, raw monthly payment. That, by the way, might have a third decimal place value or a fractional penny, which will have to round off using certain algorithm. So that's the data output table, and purpose is map out all the output variables. Now sometime we may need some additional variables which are not populated by the user, not outputted to console, rather they are just used intermediately for some computation. Well, we make out another table for that. Okay, let's do this here. In order to convert from raw monthly payment to whole dollars and whole cents, we're going to use two more variables, total pennies, which will be double type, and then rounded pennies, which will be int type. We'll show their use to you a little bit later. So you can say, okay, how do I know I'm going to need intermediate variables? Well, actually, in the beginning, you may not know that. But once you go to algorithm, you say, okay, to execute this algorithm, I'm going to need these variables as well. And that technology is called stepwise refinement. So you'll come back and redo these portions again. And at that time, you'll add that. So this has to be done in several steps. So whole document will continue to improve through several iterations. Okay, here I wanted to say this rate is monthly interest rate in decimalized fraction. So what's going to happen is the user is asked to enter rate as annual interest rate in percent, and then we will make this computation, whatever user entered in annual percent rate, we'll divide that by 1200 to get the rate, monthly interest rate in decimalized fraction. Okay. What we did in PowerPoint, we divided by 1200 there too. You remember rate divided by 1200. So that was done here, we just do it right here. I mean, we'll do the in the algorithm. Take this step in the algorithm. Okay. Understand one thing. In this document, there are line numbers. See that there are line numbers in whole document. Your submitted document must have line numbers as well. And they are very easy to create in Microsoft Word. You can look up online documentation. Whichever software you use should have a way to put line numbers for each line. And that is required because that makes it easy for me to comment, decide the line number, comment on that. Points will be taken off if your document does not have line numbers. Okay. Analysis always uses the formulas that software is going to use for the number crunching or computation. So in this case, that's the monthly payment formula. You will have this document with you when you watch this video, so you can actually pull that document out on your iPad or on your phone, and while you are watching this, you can scroll through the document as well. Okay. C++ form of this is not very hard to do because loan will be loan, square bracket and curly braces will be changed to parentheses. So loan, parentheses. But you know, multiplication is not done without asterisk, so we put the asterisk. Rate goes as rate. This rate goes as rate. Underneath is very important to see what we are doing. 1 plus rate to the power num PMT. So this has been described in tremendous detail in the video. In fact, I did 2 videos earlier. Those are posted already. But really it's not very hard to see. In using POW formula, this becomes my base, this becomes my exponent. So this part will be done like this. We call the POW function 1 plus rate is the base right here, comma. This is the exponent num PMT. that, and this whole thing is this whole thing and minus 1. Okay, and this is in parentheses, this whole thing, because this whole thing is supposed to divide rate. Okay, so different form of this formula I've shown in video how to convert from math to C++ form. This is another form, and once you understand the first one that I did in video in detail, you shouldn't have too much trouble understanding this one. Notice it's very important, and math, better you are in math, more upset you get by these things, that computer programs do not allow square bracket, curly braces, rather only grouping parentheses that are allowed are the parentheses. So every square has to be converted to parentheses, every curly brace has to be converted to parentheses, and of course parentheses are parentheses. So in C++ form, for math expression, does not allow use of curly braces or square brackets. So math geniuses, please understand that. We don't allow that. Okay, we don't allow that. Actually, it's not my fault. That's how computer programming languages are. Okay, so and as I said, above formula looks different from formula we used in video and PowerPoint used in videos, but both formulas are equivalent. Differences are that we use rate here as a fractional monthly rate, whereas in PowerPoint we use annual percent rate. That was divided by 1200 to get the monthly rate. And also in PowerPoint we had just numerator and denominator, but here we have two terms. See, this term and that term. But both forms are equivalent. Now, notice the requirement that program should print monthly payment in whole dollars and whole cents. For that we need another analysis, and that is that once we get monthly payment as a double type, I'm going to convert that into total pennies multiplied by 100. Now this might have fractional penny, by the way, and that needs to be rounded off. And the rule that is followed is that if a fractional penny is less than 0.5, then it is dropped. Otherwise, if it's 0.5 or higher, it is rounded to a full penny. Banks and IRS use this rule. So what we do that is that we take total pennies, which is double type, add 0.5 to it, cast that to int type. That gives me rounded pennies. Once something is cast to int, it cannot have fractional part. And then if I take modulus by 100, sorry, division by 100, that's going to give me whole dollars. Because division of two integers only keeps the quotient, truncates the remainder, and if I take same rounded pennies modulus with 100, that's going to just give me the cents left over, which are less than 100. That's how I get whole dollars and whole cents. We'll show this a few more times before we are done. Okay, now let's go to the algorithm. And after that, we'll be left with the task of only converting algorithm to source code, in which I'll look at the algorithm, pull out my Xcode compiler, and show you line by line how algorithm is converted into the source code. Okay, but it's very important for you to notice the rules enforced in writing algorithm, we try to make algorithm as independent as possible of programming languages. Here's the reason. Programming languages come and go, but algorithms live forever. Algorithms are immortal. That's why you cannot make it too dependent on the programming languages. There was a language called Pascal. It was the top language of its time. A day came, C language came, C++ came. It killed Pascal overnight. Nobody knows what Pascal is anymore. If you look at the program in Pascal, I don't think you can figure out the algorithms that easily from it. Although Pascal was pretty user-friendly. So algorithm in pseudocode, written in pseudocode, is something that is immortal, lives forever. Programming language come and go. They are born, they die. But it's the algorithm that lives forever. And that's why in this class, I'm going to keep hammering again and again and again forever. Emphasize algorithms, not the source code. Although source code is important as well. Okay, but algorithms are indispensable. When you go for your computer science degree, in the junior year of your class, you'll do a semester-long course called Analysis of Algorithm. It's nothing but a whole semester you're just going to analyze algorithm only. Okay? So, if you take out algorithm for computer science, there's nothing left in computer science. It's finished. There's no computer science without algorithms. That's why it is very important to write algorithms and make them as independent of the programming language as possible. So, what is not allowed in algorithms? None of these are allowed in algorithm. But you can do a translation. Where there is cout, you write word print. Where there is cin, you write word input. When you input into a variable, use comma. But that's only done in cascaded input. Oh, sorry. Okay, this is... Okay, I made a mistake here. This should be input. Input. And that should be output. Okay. So I'm fixing this document as I go along. And cascaded output is not prohibited. Cascaded input is prohibited in CS1. There are rules that I have to enforce for this entry-level programming class for the sake of simplicity of programming. So there are rules that language allows, but not necessarily allowed by me. Okay, so cascaded input in CS1 is not allowed, but cascaded output you can do. Okay. So this should be replaced by comma, and all these should be replaced endl /n by the word IOAA. There might be other things in future, and we'll tell those to you as we go along. Okay. One more time, none of these are allowed in algorithm. Acceptable choices are right here. Okay. All right. And Semicolon is not used in algorithm. So please, no semicolon in algorithm. Okay. Now, based on what we have surmised, that we'll take input, we will compute monthly payment, and we'll output our results. These are the steps in our algorithm. I'll fix that later so that whole table is on one page. So I'll discuss the steps in algorithm in a minute, but notice that algorithm has its own steps. So line numbers are fine for whole document, but you are required to have separate line numbers for the algorithm. Okay, non-numbered algorithm lines will not be accepted, and the reason why these lines do not work, because later on there will be steps within steps, which will be point something 1.9.3. So these line numbers won't work in that case, although it's good to have them too. So algorithm in your IOA for lab 2 should have its own line numbers. And here, let's say I did step 1, then 2, and I forgot something. Then I just do 1A, 1B, 1C, D, E, F, G. So that's perfectly okay. And you could do that too. So first part is declare the variables that are input and output, and of course intermediate variable or other variable that I'm going to need. And this could change when we do source code, but at least we'll get started that way. So our variables, if we look at the input table, I can declare those first. So that's actually pretty easily done because I have data type and names here. So only difference in declaring them is that in source code this will go first. In algorithm you can just use the same order. So loan as double, so that's what we do here in algorithm. Declare loan as double, rate as double, numpmt is int. So you can read this document, but step 1 is pretty much declaring all the variables. Then we need input for loan rate and numpmt. You can do them in any order you like, but I just go in the same order in which they are declared here. So print the message greeting the user, or you can actually print the actual message, and it says prompt user to input loan amount. You could do it this way, or if you want to be exactly accurate, you can do something like this: print enter the amount of loan to be taken. So prompt, or you can do this, either one is fine. This is a little better because it gives you the verbiage right here. You get to decide the verbiage right here, which will be in your source code. So slightly better. Accept and store into loan variables. That's where in source code you will do cin, and then prompt user to for annual interest rate in loan in percent, and you can do print for that if you like. But here show an example. For example, you can say if 7.2%, please enter 7.2 for 7.2% annual interest rate. So showing an example in actual cout works out very good. So accept and store in rate variable. And then remember we said earlier in the analysis that rate that goes into formula is really rate divided by 1200. So we do that computation here. We divide rate by 1200 and store it back into the rate. And then finally in user input you ask them for number of monthly payments and you store that in numpmt, And this formula is exactly what I had in the analysis section. So I can just copy and paste that. This is my raw monthly output. So I can output the raw monthly payment. Then requirement of the problem is that I'm supposed to get whole dollars and whole cents. And if there is a fractional penny, which many times there might be, I have to round it off with the rule that 0.5 or a half fractional penny rounds up to 1 penny, but anything less than 0.5 rounds down to 0. Okay, and that algorithm is done as follows. I get the from raw monthly payment, multiply that by 100, I get the total pennies. That might have a fractional penny. Okay, so but you'll get the total pennies with fractional penny in it. And then I add 0.5 to it. So if fractional penny was 0.5 or higher, then that'll become whole penny, point something. And if fractional penny was less than 0.5, then 0.5 plus fractional penny will be less than 1. Okay. When I cast in, the fractional pennies dropped off. If it became 1, it will just add to that 1, and I get the rounded pennies. Somewhere along the line, I will do a document or a content on this algorithm, because some people have trouble understanding this. So this will be done separately. In this video, or maybe I can do it in the next video, part 2 of this. In any case, this will be rounded penny, and it will be rounded off to the rule that if fractional penny was less than 0.5, then it will round off to 0, otherwise it will round off to 1 penny. And then, as I explained earlier, we get whole dollars using rounded penny by 100 and cents taking modulus by 100. Okay? And then we can print whole dollars and whole cents. Okay, so this is IOAA for loan payment program. Don't be intimidated by the fact that I came up with it so neatly, step by step. Guys, it took, okay, how long have I been giving it? 6 years and at least 10 rewrites. At least 10 rewrites it took to get to this organized form. So don't be intimidated if you cannot get your IO to be clean as we have it here. Just get going. We need you to start using this technology, and as time goes by, you'll become better and better at this. Okay, so don't worry if it's not a neat and clean thing. Of course, you do one draft, next day you revise it, third day you revise it. More drafts you do, it's going to get better and better. But I have to tell you, even to get something this clean, I've been doing this particular program for 6 years, and may have done at least 10 rewrites. So it takes a long time. So don't be discouraged if your document doesn't come out that clean. In time, it will get better and better. Okay. So this is the IOA for loan payment program. In the video number 2, I'm going to take each line of algorithm. So I'll keep 2 documents. I'll go back and forth with my algorithm and my compiler and show you how each line is converted from the algorithm to the source code. I'll see you in the next video. Thank you so much.